In this lesson, we're going to talk about triangles and the Pythagorean Theorem. It's a triangle, a figure formed by three segments joining non-collinear points. A three-sided figure. You got your triangle there. Symbol, for a symbol, we just use a little triangle. That's our symbol for a triangle. And you can classify a triangle by its angles and then by its sides. So for example, if I want to find the vertex of a triangle, so just to me the angles of that, my vertices are A, B, and C. And then if we want to name this triangle, we'll use a symbol, and then we'll just put the three vertices. You could do triangle ABC. You could also do triangle BAC, and etc. All the different permutations of ABC. Adjacent sides of an angle. The adjacent sides are the ones next to an angle. If we're talking about angle A here, the adjacent sides are going to be AC and AB, the ones next to that angle. If we're talking about angle B, that's this one here, my adjacent sides are going to be AB and BC. They contain the angle in it. And then for angle C, the adjacent sides are AC and BC. Opposite side of an angle, let me erase that. Opposite side of an angle. If I'm looking for angle A, the side opposite angle A, so here's my angle A. The side opposite would be this guy, that'd be BC. That's one opposite angle A. Very important. Opposite angle B, this is angle B. The one opposite would be AC. And then opposite angle C would be AB. Okay, interior angles and exterior angles. Interior angles is when you extend the sides of a triangle, you get either an interior angle, which are the inside angles, like 2, 3, and those are my interior angles. And if we add them up, don't forget that if you add up all the interior angles of a triangle, it equals 180. It's like that. The exterior angles are going to be the outside angles, 4, 5, and 6. Those would be my exterior angles. And those, they don't add up to 180, but what happens is if you combine an interior and exterior angles, they equal 180 because they form a linear pair. All the inside angles are 180, and then any interior angle with an exterior angle is also 180. Classifications of triangles by angles. We're going to label the triangles by their angles. The first one, in acute triangles, if all the angles are less than 90, that makes it an acute triangle. An equilateral triangle is exactly what it sounds like. They're all equal value. All the angles are going to be 60. It's the only way it works. So all 60. They all must be the same, which is 60. That's an equilateral triangle. We have a right triangle. A right triangle has one right angle. And you'll see that displayed by the little right angle symbol. So if you see that symbol, you know it's a right angle. And then a right triangle has very special properties. First, we can name these. The hypotenuse is always the one opposite the right angle. If you got the right angle, see how it kind of points? It's pointing at the hypotenuse. And the other two, which are shorter, the hypotenuse is always in the longest side. The other two that are shorter are called the legs. And the hypotenuse is the longest side because the angle here, 90 is going to be the biggest angle, has to be. To make it a 180, the hypotenuse is the largest side, and the other two sides are called legs. An obtuse triangle. An obtuse triangle is a triangle with one angle that's obtuse, one angle that's bigger than 90. That's what obtuse means. Greater than 90, but less than 180. Because if it's more than 180, you wouldn't have a triangle. That makes this an obtuse triangle. Next, we could classify triangles by the sides. So an equilateral triangle is when all the sides are the same. If all the angles and all the sides are the same, equilateral triangle. If you have one, then you have the other. In this case, all the sides are the same. And all the angles here will also be 60, we learned earlier. The equilateral triangle has all sides the same and all angles the same. An isosceles triangle means that two sides are congruent. An isosceles triangle means you have two sides congruent. And those are usually called the legs. So the legs are the two sides congruent. You can see here they have the markings. Since they both have one mark, that means that they're the same. And the base angle is the third side, the one that's not the same. A scalene triangle means that no congruent sides. All three sides are different. You see here it has one mark, 2 marks, 3 marks. They're all different. Okay, let's try an example. Let's classify these triangles by the angles and sides. So this one here, this is an equilateral triangle. You can tell all sides are the same. All angles are the same. It's equilateral. Over here, it's a right triangle and all the sides are different. So this would be a scalene. All sides are different. Right triangle though. So scalene, all the sides are different, but it does have a right angle. Scalene right triangle. The next one, oh, notice these are the same. This is an isosceles triangle. You notice these are the same, which is why these sides are the same. The next one, another scalene, but it is obtuse. See this guy's bigger than 90? That's obtuse. Obtuse scalene triangle. Okay. Now let's talk about the Pythagorean theorem. The Pythagorean theorem only works for right triangles. So it has to be a right triangle. So Pythagoras figured out. In a right triangle, remember we have a couple things. This is right angle. This is hypotenuse. And these guys are the legs. And what the Pythagorean theorem says is that if you get the two legs and you square them and add them up, it's equal to the hypotenuse squared. The leg squared plus leg squared equals hypotenuse squared. And the easy way to remember that is we label these guys A, B, and C. And we're going to get A squared plus B squared equals C squared. Now, the most common mistake I say all the time is that people just put the numbers randomly. C has to be hypotenuse. The only one that matters. For the rest, A and B doesn't matter. You make that A, you make the B. They're both legs. It doesn't matter. C has to be hypotenuse. It's the only mistake you can make. So don't make that mistake.
Square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
I guess the only mistake you can make is that, again, it has to be only right triangles. That was a famous mistake in Wizard of Oz. It has to be a right triangle.
The sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
That's a right triangle, you idiot! Go!
Okay, let's do an example then. I'm going to solve for this hypotenuse here. Again, I'm going to label the sides. We have a, b, c. Our formula is a squared plus b squared equals c squared. And the only thing that really matters is that c has to be hypotenuse. So in this case, my a is 7, my b is 24, and my c is x squared. 7 squared is 49. 24 squared is 576. Thank you, calculator. And remember, before we take the square root, you have to add these first. Order of operations. I'm going to add these, and I'm going to get 625 equals x squared. Then we'll take the square root of both sides, get rid of that squared. And that actually works out nicely. X is equal to 25. X equals 25. And that's actually, when it works out nicely, we actually have a name for it. It's called a Pythagorean triple. And we're going to talk about those later, but those are the nice ones. Next one, not going to be nice. The same idea, we're going to solve this one real quick. Now remember, A and B don't matter. I'll put A down here, I'll put B over there. But this has to be my c. The hypotenuse has to be your c. Using our formula, a squared plus b squared equals c squared. We're going to get x squared plus 4 squared equals 8 squared. Now again, it didn't really matter. A and b, it's the same, but I'll keep it in order. We have this. Now we have to simplify. X squared plus 16 is equal to 60. I'm not looking for my c, I'm looking for my x, which is a leg here, to an a. I get to this part, I have to subtract 16 from both sides. We get x squared is equal to 48. And then we have the square root. And then we have x equal to square root of 48. Now, you're not supposed to leave it like that. You want to simplify it the way I do it. I'll do upside down division. 48 divided by 2 is 24. And I can divide that by 2 and I get 12. And I divide that by 2 and I get 6. And I divide that by 2 and I get 3. Remember, I need pairs because square root. I have a pair of 2's right there. I have a pair of 2's right here. And that 3 has to stay inside. We have a 2, and a square root of 3. Also known as 4 square root 3. That's square root 48 in simplest form, 4 square root 3. Now, sometimes you have nice ones. This first one here, those are called Pythagorean triples. And if you know a couple of them, then you don't have to do the math on them. If you knew this was going to be 25, because this one's a nice one, you just have to write 25 there. So here are the most famous Pythagorean triples: 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. This one we did earlier. I would say most of the time the ones I remember all through college were these two. And then the multiples of them. You can multiply these guys by 2 and it still holds. So if you multiply this by 2, you get 6, 4, 8, I can do math, and 10. Over here you get 10, 24, and 26. Those are also Pythagorean triples. Any multiple of these is also Pythagorean triples. And here's a full list of them. And there's a lot more. I would say the ones that if you really want to make your life a little easier, it'll be this guy and its multiples, and then this guy and a couple of its multiples. If you know those, your life's a lot easier. The rest, honestly, sometimes it might just be easier to do it than to memorize these, but 3, 4, 5, and 5, 12, 13 go a long way. Okay, a couple more, and then we'll finish up here. So this will show you some of this. How does this work? Same idea. First, find your c, and then these are a and b. We're going to use our formula a squared plus b squared equals 6 rad 5 squared. Let's square this. That's 144 x squared. So how does this work? Well, what happens is you square both of them. So it is 6 squared times rad 5 squared. 6 squared is 36. Square root of 5, and the 5 does cancel out. Or you can think about it as square root of 5 times square root of 5, which is square root of 25, which is 5. Either way, they cancel out. You just get 5. Square and a square root cancel each other out. You just get 5. So this side's going to be 36 times 5, which is, this is 180. Over here, I still have the x squared, and then I still have the 144. So we got to subtract off 144. We get x squared is equal to, what is that, 36? And then we square root 36, and I know that. X equals, that's our missing side. Let's move on to the next one. Find the length of the diagonal of the square. The diagonal squared is this guy. That's what we're looking for. Make that an x. It is a square, which means all sides are the same. That's a 5 also. All we have to do is Pythagorean theorem, a, b, c. We're going to get 5 squared plus 5 squared equals x squared. 25 plus 25 is equal to x squared. I get 50 is equal to x squared. Square root both sides. Now you could leave this, will be a little off. You want to simplify it. So let's try to simplify 50. I do upside down division. So the 50 divided by 2 is 25. 25 divided by 5 is 5 and 5. I have a pair of 5s and the 2 gets left over. So this is just going to be 5 square root of 2. That's what our x is, 5 square root of 2. Okay, last problem. Let's find x here. So they tell me the whole thing is 12. First, I probably want to figure out what this side is. It'll help me figure out what this side is. And once I figure out that side, I could do a squared plus b squared equals c squared. Now here, this is 10 and that's 6. This is actually a 3, 4, 5 triangle. 5, but if you get that triangle, you times it by 2, it's 6, 8, 10. That's what this is. This is like a special triangle. It's 6, 8, 10. If that's 8, that means this guy must be 4. 12 minus 8, 4. I have this side. That is not a special triangle. All we have to do is Pythagorean theorem. A squared plus b squared equals c squared. C has to be hypotenuse. Here's my right angle. X is my c. So this is going to be 4 squared plus 6 squared equals x squared. I'll bring it over there. 16 plus 36 equals x squared. Add those two, I get 52 equals x squared. Square root both sides. And again, we want to simplify this if we can. When I look at it, divided by 2, I get 26. Divided by 2, I get 13. 13 is prime, can't go any further. So of a pair of 2s, those come out. The 13 is left inside. There we go. That's the video.